Hi, Tens. Welcome to what is now going to be part 2 of today's lesson. I only had 15 minutes to record the first lesson, so I actually got cut short and we'll have to continue here. Anyway, let's get into it. We're up to talking about the third item on the agenda, which was writing chemical equations. And it's just a brief overview of how we do that in worded and symbolic form. So, as you probably all know by now, the easy, simple way to break down how we write a chemical equation is essentially we are turning reactants into products. We do that by using this arrow here to represent that there's been a change from what you put into the reaction to what is coming out the other side. So the reactions are what we put in, products are what comes out. These are your definitions there. So, when you're writing a chemical equation and it gives you a situation or an example like the above, you need to figure out, you have to pretty much pick it apart and take what information you need out of it and then turn it into an equation. So if you're being asked to write a worded equation, or if you need to write a worded equation from, say, an experiment or some sort of other example, you would just be picking out the reactants and the products. So that's what you do here. So you figure out exactly what the reactants are, which would in this case be hydrochloric acid and sodium hydroxide, because they are being mixed to combine. They combine to form a solution of sodium chloride and water. Okay, then your products will be down here. Okay, so the only thing that this is probably missing is your states. So if this question was asking you to include states as well, then you would go ahead and put your states in brackets at the end. Most of the time we do this in a symbolic equation, but sometimes you could be asked to do that also in a worded equation. So with states, this is one that some people try and remember a lot of them. And sometimes you can get quite confused at what might be a solid and what might be aqueous. That's pretty much the one that I find is the most sort of hard to figure out. So in this one, you've got hydrochloric acid and sodium hydroxide. These will both be aqueous solutions because acids essentially are just dissolved in water because they can be diluted and you don't know what the dilution is. And then a sodium hydroxide solution would also be aqueous. Moving across, you would see that it's forming it's an acid and base pretty much forming a salt and water. So you would say that your sodium chloride would probably be solid as you are forming some sort of salt, precipitate. Could be aqueous as well, depending on what happens in the reaction, but it's likely to be solid here. Water we would label as a liquid. It's not aqueous, as aqueous means that it is a substance dissolved in water. However, you could argue that if you were using water from the tap, that it is aqueous because it is not actually a pure substance. So here's another one that's asking you to do the same formula, but using symbolic equations. So here you've got exactly the same process. So you figure out what your reactants are, and you know that HCl is hydrochloric acid. Hydrochloric acid, H. It's a hydrogen and a chlorine, and its formula is HCl. This is one you guys will just pick up along the way as you're going through chemistry. Again, sodium hydroxide, a base, you will figure out that that is a lot of the time just written as NaOH, and that's because the charges here are equal opposites. Same as HCl, very similar to ionic bonding. You will see that the charges on each of these are positive one on the hydrogen and negative one on the chlorine, which means that they're a really good fit for each other. So they are forming a ionic compound, which is sodium chloride and water. So we know what water is, it's H2O, so we can write that in our products section here. And then sodium chloride is, you've just got Na and Cl. And if you ever have an ionic compound, you just got to match up the charges or you have to add one more of or less of either component to make the charges equal. Again, in this case, NaCl, Na has a charge of +1, chlorine -1, therefore you would just have NaCl. You don't need to add anything else. So here's the one where I would like you guys to have a go. So if you could pause your video now, read through this, and then I will show you guys the answer. So hopefully you got sodium chloride plus silver nitrate forms silver chloride and sodium nitrate in that order, going across like that. So the next one is a little bit more difficult, as I haven't given you the symbolic products and reactants for this equation. So please go ahead and figure those out now and then write it in a symbolic equation, please. Pause the video and go ahead and do that. So here are the reactants. They are NaCl and AgNO3. So NO3 stems from the fact that nitrate is an NO3 group. So if you ever see that there's a nitrate, it means it's an NO3 all as one component, and it's made up of a nitrogen and 3 oxygens. They are binding to a silver, a molecule of silver here. The products will be AgCl and NO3. So going forward, you will see that this is a double replacement, and that's something we've learned a bit more recently since we began learning about symbolic equations. Here is the final equation, again, without states included, but these would all be aqueous solutions, and you would go from there. So, just to leave you with this, here are a few different examples you can have a try at. Feel free to have a go at all of these. Check your answers over using a periodic table, and you can even search up the reaction that's taking place to see how you went. If there are any questions about any of these, that's when you need to email your teacher. That would be myself, Miss Withers, or Miss Quay, and we can give you some more detailed explanations on what's happening here. Anyway, thanks for the lesson, guys. Take care. Good luck on the exam.